Okay, here is video number 2 for today. This is for 4.1.4. How do I determine the LSRL? Well, the good news is Desmos does it for you. But what we're going to do is we are going to look and see how Desmos does that, or at least how to get Desmos to do that. So looking at problem 431 here, it's got all this data. The good news is down below, all of this data will be input into Desmos for us, so we don't have to type this all in. It's an interesting problem. They're talking about the El Toro professional basketball team. That translates to the Bull. This is a loosely veiled allusion to the Bulls of the early 90s with Michael Jordan, Scottie Pippen, Dennis Rodman, all these other guys. And all these names have been kind of put in there. Instead of Michael Jordan, they got Scottie Sorden. Instead of Scottie Pippen, they got Mike Lippen. Instead of Don Harper, they got Don Carper. Luke Longley is actually Luke Shortley. All these guys, they just kind of converted the names. Kind of fun. I like it. I like basketball. Of course, I'm a Lakers fan. But anyways, the Bulls of the 90s were some of the greatest teams ever. So then, anyway, they got their minutes played, they got their points scored, and we're going to take a look at this scatter plot. So if you go down to 434, we're going to skip to that E tool just to be able to talk through this when we talk about a least squares regression line. I mentioned that in our notes the other day. Least squares regression line is the best line of best fit. And so if we click on here, the 434 E tool, it takes us to all this data. And if we look, you can see there's all the data. Way up in the upper right-hand corner, that is Scottie Sorden, a.k.a. Michael Jordan. That is, what do they call him? Mike Lippen, a.k.a. Scottie Pippen. So, and there's everybody else. Now, what we're going to do is we're going to come up with the LSRL here. This purple line here is for you to kind of just go, okay, well, let's see. What would be a good line of best fit here? I'm going to just kind of make my own estimate. Remember, what we might want to do is go, well, let's get rid of the outliers. Looks like we got 3 outliers, and maybe that's our better line of best fit if we're really going to make a true prediction. However, we're going to use all the data, and so if we're going to try and make our best line of best fit, I don't know, something like that. Definitely ought to go through 0, 0, since you can't score negative points down here for 0 minutes, although sometimes the line of best fit doesn't necessarily fit real data all the time. So I don't know, let's do something like that. Get kind of close to it. Hopefully we'll see what the real thing looks like. It's kind of a little off because of the outliers, and we'll just see what we get. Now, if we look over here on the left, there's a lot of explaining going on there. And so take your time to read through that when you go through this yourself and you open up the E tool. We're going to look at how to do this here. So here's all the data. Again, we got X1 and Y1 in there. And the part that I really want to get to is how to write, using Desmos, the function that will draw the real line of best fit. So we're going to go down here. This X1 and this Y1, these are the sums of the 2 columns. We don't really need those right now. That's just, use that kind of just to check that you've entered all the data correctly. Though a lot of times they'll give you those sums so that you can go back and if you type in that into Desmos, it sums up the columns for you. You can double check that you did everything, you typed everything in correctly. So inaccurately, not inaccurate or incorrect, correctly typed it in. Okay, so use your calculator to determine the LSRL and graph it on your calculator, then sketch the scatter plot and LSRL on your paper. So the main thing that you need down here is this. That right there, that's what you're going to type into Desmos, the Y1, the little tilde thing, the MX1 plus B. Type that in, and that will automatically draw the line of best fit for you. So we don't need any of this other stuff. We'll just go up here to the plus button, upper left-hand corner, hit expression, and then we're just got to type that in. So it's just Y sub 1. They automatically do the sub 1. Then you got to go find the tilde. It's under the ABC part of the key right there. and then we're going to do M, that's for our slope, and then X, and we need the 1 after it, so go put the 1 there, okay, and then plus B, so we're going to go back to the ABC thing there, and there it is. There's the real line of best fit drawn in blue. Mine was kind of terrible, so maybe if I would have, so you can see, so that's what they say the real line of best fit is. Okay, I'm going to get mine out of there because it was so awful. But it's just kind of nice to see what your prediction is compared to what the real line of best fit is. And again, I think without those outliers, then we would have had a true line of best fit. And you can always get rid of data points on a table. Like you could go get rid of some of those outliers, and then it'll correct the LSRL for you. So now looking over here, this is super important for us to start to recognize. Okay, we're going to get into all of this other stuff soon, but the main things I want you to see right now are under parameters. It has M. It gives you the slope. That's the slope, 0.594673, and that's the y-intercept, -208. So again, a negative y-intercept doesn't make sense for someone that plays 0 minutes, or even a few minutes in, they'd still be scoring negative points, so that doesn't make total sense, but it makes sense for the equation as a whole. So if you were to write the equation, write the LSRL, you would write y equals, then put that slope in there, 0.594673x plus or minus, I guess, 208.736. And that's your LSRL. Now, I want you to look at something else. We're going to get to the R and the R squared later this year, or in this chapter, but look at the residuals, E1. So what happens with this? This is going to be something you're going to need to start to get used to, a residual plot. What it does is it will calculate all the residuals. Okay, we talked about residuals recently. Calculate all the residuals of those for you, and then it'll plot them in relation to the x-axis. So watch what happens when I push that button right there. Okay, so there's the positive and negative residuals, and it essentially shows you with the point that's directly above it. So if you look at this outlier here with Michael Jordan up top and this black dot way up there, okay, that one, okay, and then that's the most extreme residual right there. So look at how far away, you can see how far away he is from the line of best fit. And if you look at the coordinates there, he's 862.196 points away from the line of best fit. That's how far above the line of best fit he is. Okay, but all these little green dots, if you, it's not letting me unplot it, I'm not sure why, but all those green dots, those are the residuals plotted in relation to the x-axis. If they're below the x-axis, they have a negative residual. Above the x-axis, they have the positive residual. And you can see that they match up perfectly with the points that are already there. So, for example, I did not mean to do that. I just changed the scale. Okay, but if we look right here at 7.5, so that's someone that played for 7 minutes and scored 5 points, and then click above that there, okay, the 5 points is actually 209.573 above the expected points value for someone who played 7 minutes according to the line of best fit. But again, this line is skewed by the outliers. So but you can look at each of those. So the green dots, those are the residuals. That's the residual plot. And I don't know what's going on here, but Desmos doesn't usually make that. You're supposed to be able to hit that plot button, turn it on, turn it off, turn it on, turn it off, so you can get rid of the green residual plots just to look and see it. But that's how you type in the LSRL. You can then use that as your line of best fit. If you want to make any sort of predictions, you would put the input in, see what the expected value is out. And that's how you find the LSRL. Again, it's just this typing in this function. Y1 is approximately mx1 plus b. So that's it.